There's one last thing that we're going to talk about in chapter 17, and this is the different factors that have an effect on the solubility of these insoluble solids. So for this example, we're just going to go straight to a reaction. Calcium fluoride, which is a solid, and it is in equilibrium with its calcium ions and 2 fluoride ions. And we are going to consider the scenario. What would happen to solubility of the calcium fluoride CaF2 solid if sodium fluoride is added? What's going to happen if sodium fluoride is added? So first of all, I want to talk about what this question is actually asking you. When it says what happens to the solubility, what exactly do they mean by that? Do they mean, or they are asking you, does more calcium fluoride dissolve? As in the equilibrium moves to the right so that more of it can dissociate and dissolve? Or does less of it dissolve? So do some of those ions that have already been dissolved, do they come back together and re-solidify so that less is dissolved? And that would involve equilibrium shifting to the left towards the side of the chemical reaction that has the solid substance on it. So that's what this question is asking. What happens to the solubility? Does more or less dissolve? If we add sodium fluoride, the second thing that we have to think about is, what does sodium fluoride do, or what can it do? What can sodium fluoride do to our equilibrium? In order to figure out what sodium fluoride could do, we have to think about what sodium fluoride is made up of. When we put sodium fluoride in water, it dissociates, and it dissociates completely, and it makes sodium ions and fluoride ions. So what we're trying to ask ourselves here is, are either of these ions already present in our reaction? Are either one of them already present up here in this reaction? Because if they are, if either one of these ions are already present, they are going to be called or considered common ions, which will have an effect on the position of equilibrium. So we're going to look at both of these ions. Sodium Na+, we do not have in this reaction, but fluoride F-, we do have in this reaction. It's a common ion. That fluoride ion is already present in the calcium fluoride system, which means that it's going to have an effect on the equilibrium. Adding additional fluoride will affect the equilibrium using Le Chatelier's principle. So let's think about how. If we add more fluoride ion, and here we're adding it from sodium fluoride, NaF, this is going to cause the concentration of fluoride to increase. And if the concentration of our fluoride increases, this amount increases, the fluoride ion concentration gets too large, the system is no longer in equilibrium because it has too much fluoride ion, and it's going to respond by pushing the reaction to the left, pushing the position of equilibrium to the left to try to use up some of this extra fluoride and get rid of it and get its amount down, back down to what is normal. So when we're pushing the system of equilibrium to the left, away from that added fluoride, equilibrium shifts left, and this causes an increase the amount to the amount of calcium fluoride, CaF2 solid. Shifting to the left means that less of our calcium fluoride is dissolved. The answer to this question is that the calcium fluoride solubility decreases. It is less soluble because we have formed a larger amount of solid. There's another way that we could look at this type of problem. So this is one way we could look at it, just with a straight up common ion type thing. Another way that we could look at this problem would be, we're going to use a different equilibrium system this time, FeOH3, solid, in equilibrium with Fe3 plus, aqueous, and 3OH minus. And this time we're going to ask ourselves, what happens to the solubility of the iron 3 hydroxide, FeOH3, if our pH increases. So this is a different type of question. Still, we want to still start by breaking down what is this question asks us when it says, what happens to the solubility? That just means, again, it means, does more of our solid dissolve? And that would involve shifting the equilibrium to the right. That would make more solid dissolve. Or it's asking the other scenario, does less of our solid dissolve? In order for that, we would have our position of equilibrium shifting to the left, less dissolving. So what is going to happen in this case? So just like with the last problem, we're going to want to ask ourselves, what can the pH do to this system of equilibrium? And this is a little bit different than the last example, because the last time we said, what can NaF do? And do we have any Na plus? And do we have any F minus? And can we use that as a starting point for this analysis? And here we're just asking about pH. What can the pH do? So remember that pH is reflecting acids and bases. Do we have any of those? Do we have an acid or a base? Well, if we remember back to chapter 16, I don't remember which section it is, I want to say 1610, we did go through a thing on what are the acids and what are the bases, what are the acidic cations, what are the basic anions. And one thing that we talked about in that section, and really all of chapter 16, was that hydroxide is a very strong base. It is our strong base. And so it is going to be completely tied and affected by any changes that we might make to the pH of the solution. If we are, let's see, what are we doing here? If we are increasing the pH, that means that we are making the solution more basic. Low on the pH scale is acidic, high on the pH scale is basic. So if we're increasing the pH, that means we're making the solution more basic, which means that we are increasing the amount of bases that we have in our solution. Specifically, we're increasing the hydroxide ion concentration in this solution. So this amount, the amount of hydroxide ion concentration, is going to go up. And when that concentration goes up, the position of equilibrium is going to shift to the left to try to get rid of the extra hydroxide that is now present. When the position of equilibrium shifts to the left, the amount of FeOH3 is going to increase. So we will have more stuff in the solid form and less stuff dissolved. This means that the iron hydroxide, FeOH3, its solubility decreases.